Welcome! Today, we're diving into exploratory data analysis, or EDA, using the powerful software SPSS. Our goal is to uncover meaningful insights and discover hidden patterns within your valuable data. Let's explore some common and highly useful data visualization tools available right within SPSS. These tools are crucial for visually understanding data distributions and identifying patterns efficiently. First up, we have bar charts, a fundamental tool for visualizing categorical data. Bar charts are excellent for comparing the frequencies of different categories within your dataset. Next, we'll look at pie charts, another popular way to represent categorical data. Pie charts effectively represent categorical data, showing each category as a proportion of the entire whole. Then, we'll cover histograms, which are essential for understanding numerical data distributions. Histograms show the distribution of numerical data, helping us identify skewness and overall shape. Finally, we have box plots, a very powerful tool for summarizing data visually. Box plots summarize data distribution, highlight central tendency, spread, and effectively pinpoint any outliers. Now, let's learn how to generate frequency tables and bar charts step by step in SPSS. This section will guide you through the precise, step-by-step process of creating these visualizations in SPSS. The very first step is to correctly load your specific dataset into the SPSS software environment. This involves opening SPSS, then navigating to load your desired dataset into the program. After loading, you will navigate through the SPSS menus to find the Frequencies option for tables. You will go to Analyze, then Descriptive Statistics, and finally select the Frequencies command. Next, you need to carefully select the variables you wish to analyze and then confirm your choice. Simply select your desired variable or variables from the list, then click OK to proceed. To create a bar chart, you will access the Legacy dialogues specifically designed for graphs. Navigate to Graphs, then Legacy dialogues, and from there, choose the bar chart option. At this point, we need to define the specific type of simple bar chart we want to generate. You will choose the simple bar chart type, and then click on the Define button. Finally, select the specific variable you want to visualize, and then generate the chart. Choose your desired variable for the chart, then click OK to display your completed bar chart. Let's now delve into the essential descriptive statistics used to summarize data. These statistics are fundamental for summarizing key data characteristics and gaining initial understanding. The mean is the average of all values in a dataset, but it can be sensitive to outliers. The median is the middle value in an ordered dataset, making it less affected by extreme outliers. The mode is the most frequently occurring value, identifying the dominant categories in your data. Standard deviation measures how much data points typically disperse or spread out around the mean. The range is the difference between the highest and lowest values, showing the overall data spread. Let's now walk through the step-by-step process of performing a cross-tabulation analysis in SPSS. First, you'll need to load your dataset into SPSS, ensuring all your variables are correctly defined and prepared. Next, navigate to the Analyze menu, select Descriptive Statistics, and then choose Crosstabs to open the dialog box. Here, you will select the categorical variables you wish to analyze, typically placing one in rows and another in columns. Then, click on the Statistics button to choose relevant options like chi-square or other association measures for your analysis. After selecting your variables and statistics, click OK to generate the cross-tabulation table in the Output viewer. Finally, carefully interpret the percentages and statistical tests to understand the relationships between your chosen variables. Now, let's delve into understanding t-tests, a fundamental statistical tool for comparing group means. The primary goal of t-tests is to compare means across different groups, helping us identify significant differences. First, we have the independent samples t-test, used for comparing two distinct and unrelated groups. This test compares the average scores, or means between two different groups that are not related to each other. It assumes that your data is normally distributed and that the variances within both groups are approximately equal. For example, you could use this to compare the average test scores of male students versus female students. Next, we examine the paired samples t-test, which is suitable for related groups or repeated measurements. This test is applied when the same group is measured twice, like before and after an intervention, or for matched pairs. It assesses whether the mean difference between these two related measurements is statistically significant. A common example is comparing the pre-test scores and post-test scores of the exact same group of students. Let's now explore the general linear model, or GLM, a highly versatile statistical framework. At its core, the GLM is represented by a foundational equation that describes relationships between variables. This is the core formula, often referred to as the GLM equation, which underpins many statistical tests. The equation is y equals beta naught plus beta 1x1 plus beta 2x2, and so on, up to beta nxn plus epsilon. In this equation, y represents your dependent or outcome variable, the one you are trying to predict. x1 through xn are your independent or predictor variables, influencing the outcome. Beta naught is the intercept, which is the expected value of y when all x variables are 0. Beta 1 through beta n are the coefficients of your predictors, showing their individual impact on y. Finally, epsilon represents the error term, accounting for the unexplained variance or residuals in the model. Essentially, the general linear model extends simple linear regression to include multiple predictor variables. This powerful model allows us to effectively analyze and understand complex relationships between various variables. Understanding the general linear model is crucial due to its significant benefits in statistical analysis. It provides a powerful and incredibly versatile statistical framework for handling diverse research questions. One major benefit is its flexible analysis capability, adapting to various data structures. The GLM can simultaneously analyze multiple dependent variables, offering a comprehensive view of your data. It also accommodates diverse predictors, making it suitable for many different types of data. You can use both categorical and continuous independent variables within the same general linear model. Furthermore, GLM excels in covariate control, enhancing the precision of your results. It effectively reduces errors and potential bias by allowing you to control for extraneous influencing factors. Finally, the GLM forms the foundation for many advanced statistical methods and analyses. It serves as a basis for techniques like EMA-NOV and repeated measures analysis, expanding your analytical capabilities. All right, let's now summarize our key learnings from this comprehensive session on exploratory data analysis in SPSS. We will focus on the most important takeaways for performing effective exploratory data analysis using SPSS. Remember, data visualization with tables and charts is crucial for revealing distributions and identifying trends within your data. Descriptive statistics help us summarize central tendencies and understand the overall variability present in our datasets. Cross-tabulations are invaluable for identifying and understanding relationships between different categorical variables effectively. T-tests and a NOV are essential statistical tools for effectively comparing means across various groups in your study. Finally, the general linear model provides a highly flexible framework for handling complex statistical modeling tasks efficiently.